Across the savannas and skylines of a continent once written out of the great scientific revolutions, a quiet transformation is unfolding. In hidden laboratories, university corridors, and digital classrooms, African physicists are reaching for the universe's deepest secrets. This is the African Quantum Leap, the story of a new scientific frontier rising from the global south, one that could rewrite the laws of physics and change the balance of global power. It begins in South Africa, at the National Institute for Theoretical Physics in Stellenbosch. Once focused on classical physics, it now houses Africa's first quantum information research group, collaborating with IBM and CERN. Here, Dr. Jonathan Pillay and his team experiment with superconducting qubits, the basic units of quantum computing. Their goal, to create a stable qubit that functions in warmer climates, potentially revolutionizing computing in regions where cooling infrastructure is scarce. Dr. Pillay said, "If we can build quantum systems that work at African temperatures, we can build them anywhere. It's not an isolated dream." Across the continent, from Rwanda's Innovation City to Nigeria's Quantum Computing Research Network, new labs are blooming, each contributing a piece to Africa's quantum puzzle. Rwanda has launched the Africa Institute for Mathematical Sciences Quantum Hub, a center dedicated to quantum machine learning. Meanwhile, in Lagos, the Quantum ICT Initiative, backed by the African Development Bank, trains young engineers in quantum encryption for cybersecurity. For decades, Africa was seen as the end user of foreign technologies. Now, it's becoming a producer of original scientific thought. Behind an unmarked door outside Pretoria, a collaborative facility, quietly referred to as the Array, operates at the intersection of physics and defense. It's a joint project between South Africa's CSIR, the University of Cape Town, and private tech firms. Its mission, to develop quantum-secure communication systems that could protect the continent's data from cyber threats and foreign surveillance. Few outside its staff know the full extent of the research, but one engineer describes it as the digital equivalent of independence, and that word, independence, defines the deeper meaning of Africa's quantum push. This isn't only about technology, it's about sovereignty, owning the code, the hardware, and the future. At the African Union headquarters, a new phrase has entered policy language, Quantum Africa 2035. It's part of the Science, Technology and Innovation Strategy 2024 to 2034, outlining plans for a continental quantum network linking national labs through high-speed fiber optics. Under this plan, research data from Cape Town, Nairobi, and Accra will be mirrored in real time, ensuring that knowledge, once exported, now remains within African borders. Dr. Makgadi Makona, one of the architects, explains, "For years, our data was stored abroad. Quantum Africa brings our information and our imagination back home. This vision extends beyond physics into power. Quantum computers need enormous energy, and Africa's renewable energy expertise offers an advantage." The Council for Scientific and Industrial Research is developing quantum-ready microgrids, drawing power from solar and hydrogen sources first tested at the Square Kilometre Array Telescope. If the prototype succeeds, the world's first zero-carbon quantum data centers may rise in the deserts of Northern Cape. Clean, efficient, and African-owned. Quantum chips rely on rare minerals, niobium, tantalum, yttrium, all abundant beneath African soil. From Zambia to the DRC, old copper mines are being retooled for quantum-grade materials. A new tech corridor from Katanga to Dar es Salaam is emerging, exporting processed superconducting alloys instead of raw ore. Economists estimate that if Africa captures even 10% of the global quantum hardware supply chain, it could add $20 billion annually to continental GDP. But a philosophical question lingers. Should Africa once again export the ingredients for someone else's technology, or build its own foundries? Professor Aisha Mwangi of the Kenya National Research Fund is unequivocal. We missed the semiconductor revolution. We will not miss the quantum one. In Nairobi's Konza Technopolis, pilot fabrication labs are already operational, where engineers are developing photonic circuits tailored for quantum processors. The world has taken notice. The EU, China, and the US are all courting African partnerships in quantum research. The European Union funds scholarships and fiber infrastructure. China invests in photonic manufacturing plants in Ethiopia. IBM Q and Osbraket are opening African quantum cloud access programs. Yet African negotiators remain cautious. Dr. Emeka Konjo, who led Nigeria's 2025 quantum framework talks, notes, "We'll collaborate, but we won't repeat history. Intellectual property must stay in African hands." That approach has birthed a new diplomacy, quantum alliances instead of traditional trade blocs, science replacing commodities as the language of power. Behind every equation are people, young Africans rewriting what's possible. Programs like Qiskit Africa, Quantum Hub Egypt, and the African Quantum Scholars Network now train thousands of students across 20 countries. Open source materials and satellite internet have erased the old boundaries between privilege and potential. My village loses crops to drought. If I can model the climate with a quantum computer, maybe I can stop it before it happens. For this generation, physics isn't abstract. It's survival, a way to forecast weather, secure data, even diagnose diseases faster. Quantum isn't an elite dream anymore. It's a continental necessity. At the University of Cape Town's Philosophy of Physics unit, scientists and philosophers meet to ask deeper questions. What does quantum entanglement, the idea that particles remain connected across space, mean through the lens of Ubuntu? Dr. Namsa Pillay puts it simply, Ubuntu says I am because we are. In a way, quantum physics has always said the same. From these dialogues emerges an ethical framework for African AI and quantum governance, ensuring technology develops in harmony with human values, not apart from them. Kenya's Silicon Savannah is evolving into the quantum savannah. Startups are developing quantum sensors that measure soil health with near-atomic precision. Field tests in Machakos County show crop yields rising by 40%. Imagine an Africa where every farmer has access to quantum-level data, every clinic simulates molecules for new medicines, and every student learns quantum coding in their native language. That vision is no longer science fiction, it's policy in motion. By 2040, Africa's scientific roadmap aims for 5 continental quantum-class data centers and indigenous qubit processor built entirely in Africa, a Pan-African education network connecting 50 universities, zero-carbon quantum grids powering major cities. Experts predict the continent could command 5% of global quantum IP by then, a $1 trillion market segment. Dr. Bakari, from Lagos, captures the spirit. Quantum technology is faith in the unseen. And Africa has always believed in things beyond sight. Quantum science isn't just changing Africa's technology. It's changing its place in the universe. A century ago, Einstein rewrote space and time. Today, a new generation, from Johannesburg to Kigali, is rewriting the next chapter. The African quantum leap is more than a project. It's a philosophy that the smallest particles can ignite the largest transformations. And perhaps, when the history of physics is rewritten once again, it won't begin in Princeton or Zurich, but here, under African skies, where the future of the universe is already being imagined.